One of the interesting things about science and the philosophy of science is the question of can science actually reveal things that we can't see? And I believe the answer is yes. And we're living it as we were watching things that we couldn't see years ago. Now we can visibly see the evidence. So it's an exciting time to live, an exciting time to be an educator. Now, I can introduce myself. I'm Dr. Appea, and I'm the Curriculum and Secondary Coordinator at Sharjah American International School in Sharjah campus. And I've been interested in mind-body relationships since back when Mr. Jadal and I were in college, and reading Plato, Aristotle, and Socrates. And it's interesting, back then, 2,500 years ago, of course, they could only speculate on what was inside our brain. But now, thanks to technology, we can actually see what our brain looks like. And what we can't yet see thoughts and emotions, but we can track blood flow, and we can see which part of the brain is regulating our emotions and our thoughts. So one of the things that was very interesting to me back in the 90s was the development of this technology called functional magnetic resonance imaging. I'm supposed to stand on this scarf? Okay. All right. So what it does is basically track blood flow to in areas of the brain when we feel certain things. Has anybody here ever been in an MRI? Yes. Okay, so if you had an accident or an injury, they put you in this MRI. Now the fMRI works the same way, except for it tracks the blood flow of your brain. So the way that we try to control people's brains when they have problems is through basically psychotherapy, therapy, drugs, and fancy knives. So personally, I prefer this neuroimagery, the new neuroimagery techniques. And especially when you consider the life of an adolescent. Now, we are, many of us, parents and educators at Sharjah American International School, and parents all over the world, and researchers all over the world are trying to figure out what is wrong with those adolescents. And the question is what is wrong, but also what is right. So that's why I've entitled this The Promises and the Perils of Adolescence. So looking at some of the main problems that adolescents face, you can see that there's quite a list. And so it's no wonder that this time from 10 years old to 24 years old, to 25 really, you've got all of these things to worry about. So it's no wonder that there's a lot of turbulence during those years. One of the things I was reading was the definition of adolescence includes when the long bones stop growing and the hormones start flowing. When the hormones start flowing and the long bones stop growing. So that's a good way. But that encompasses a lot of years. That's 15 years of life. Many of you in this room are in that stage. So here's where and look at some of the resources that are available to us right now. I'm just going to see if I can. Mahmoud or somebody around here. I want to click on this link. Okay, so this is the, can you hear me? Yeah. This is the what the brain looks like. It's an interesting resource in the New York Times. You can see what the brain looks like from childhood through beginning of adulthood. So the red areas indicate relative immaturity, and the blue is maturity. So if you click on the next age, so this is 4 years old, go to 9 years old, and you can see that these areas are developing. You can see that at a certain age 9, parietal lobe is beginning to develop, and that allows children to acquire math and geometry skills. In addition, fine motor skills develop. And getting into adolescence, you can see that the brain has definitely matured. One interesting thing is that although there's a lot of neural connections, those are not used or pruned away, so they disappeared. And we go into, let's go to 21, and you can see that here, the brain's mostly mature, but there's still room for increases in emotional maturity that even past age 21. And that's where the 25 becomes the target for when you can say that you're a full adult. So for any parents in the room, there's an expression, keep them alive until they're 25. So once they're 25, then they are fully mature adults from a biological perspective. Now, of course, these there are many cultural differences, and in this society, I believe, correct me if I'm wrong, but I believe that many young people get married at age 18, 19. And so therefore, it's an interesting question when young people get married, when they're not, let's say, fully mature, there can still be problems in the relationship that may have some biological roots. Okay, so one of the points I want to make here, in the 14-year-old brain now, they say that 50% of the problems that we have as adults stem from back when you were 14 years old. So any problem that you have as an adolescent can easily continue on into adulthood. Now, one of the issues about 14-year-old is that the limbic systems are not fully developed, but they're further along than the prefrontal cortex. So the action based on emotion is there, but the control of that is not there. Something that my car uses instead of so by the time you get to 19, you're more able to regulate your emotions. So when you get to that 18, 19-year-old point, the beauty of adolescence is that you're filled with a sense of optimism and idealism, and you're ready to engage with the world. So that's part of it. It's not all bad news. There's a lot of good news, of course. So let's see, just quickly a little bit about how the limbic system controls emotions. You've got the amygdala, which basically sends out chemicals to control exercise and stimulants through our body through the use of neurotransmitters. The hippocampus deals with memory, and I won't go through all of that. But basically, the limbic system is the seat of emotion, and it operates through what some have called happy chemicals. So dopamine, serotonin, endorphin, and oxytocin are known as the gang of four happy chemicals that you can't really read this, but basically when you accomplish a goal, dopamine is increased. When you're in pain, your body releases endorphin. When you are feeling trust or bonding, oxytocin is involved, and when you're feeling pride or sadness, serotonin is definitely involved. When we're under stress, there's I'm going to need to Welly. When we're under stress, there's all right, so this video just is a quick video about fight or flight and what happens during.
Human beings have survived down through the ages because of the body's ability to leap into action when confronted by danger. When confronted by a threat, an alarm bell goes off in your brain, triggering a chain reaction to gear you up for instant action. Adrenaline and cortisol hormones flood into your body, kick-starting the nervous system. Your heart pumps faster to increase the flow of blood to the muscles. Your breathing accelerates to take in oxygen. Muscles tighten, your fists clench. To conserve energy, digestive and immune systems slow down. To keep the body cool, you start to sweat. You are now ready for physical action. This served our ancestors well. In their charged up state, they could either fight or run away. Hence, the stress response is also known as fight or flight.
Unfortunately, the fight-flight instinct is still with us today. There are still people who become overly aggressive with other people, or run away from problems. These aren't bad focus strategies. In today's world, we can gain control of a lot of things that hit us. And we can think of strategies which are much more effective and much more effective.
Should have told him to stay here. Okay, so that was a quick summary of the fight or flight, which is a major stressor. And it's not just when we're running away from something physically right in front of us. It can be a memory. It can be a thought. It can be an interaction. So cortisol is involved in many of these negative or bad feelings. Okay, so fortunately, as human beings, we have a highly developed frontal cortex, neocortex, and through these mechanisms, we're able to control our limbic system. The way that it works is through the synapse. Those of you who've taken basic biology probably remember this. But when cells are communicating with each other, they use the neurotransmitters. And there's a lot of electrical magnetism and chemistry involved in there. And obviously it's a complex topic. There's a lot of chemical messengers involved. But the bottom line is that the limbic system uses chemicals to control and express our emotions. So one of the exciting things for me is that we have protocols, established protocols to help adolescents regulate their emotions. We can teach each other to recognize emotions, understand emotions, label them, express them, and finally regulate them. I did some work with a professor at Yale University named Mark Brackett, who's the founder of the Ruler model. And he demonstrated that when we teach adolescents how to control their emotions, we can increase their chances for success. Social emotional intelligence, EI, or emotional intelligence, is a branch of social emotional intelligence. And basically, these self-management and goal-related skills are part of the new 21st century skills, the soft skills, that are required for a successful career experience, college and career experience. So I start with the brain, I end with the brain. And there are studies now that show that we can control our emotions simply by flexing and looking at where images of which part of the brain is being identified as a pain spot. So these chronic pain areas can be controlled simply through various protocols of flexing, breathing, and moving. So it's exciting for me to think that in a few years, probably the next generation, we're going to be able to teach people how to do this when they're in pain. So for not just the physical pain, but emotional pain. So somebody comes into the office and says, I'm sad, I'm depressed or something. So when you go to the guidance counselor, you might be able to strap on some sensor, visualize a part of your brain, and help to reduce pain like that. So it's a brave new world, and it's exciting to think about these possibilities. And I hope that one day I'll come back here and hear about one of you being a scientist to help other students and and people to